value quadratic equation here today. And I would like to sketch a little bit of a graph because this is something possible to hand sketch. Now, we'll just call this 1 right here. Now, y'all, this minus 5, 6 just means to shift the graph to the right. It's pretty well-known result, just graphing transformation. So absolute value is going to look something about like this. Just a V shifted to the right. And this is 1, and that's supposed to be 5, 6 right there, okay? Now, in a similar fashion, this is a vertical shift, actually. And so it'll start down here. 17 over 6 is about -3, right? And so I'll count down 1, 2, 3 units. All right, and so we're going to have a parabola that opens up starting about right there. So we're getting something maybe like this, okay? And y'all, again, just a hand sketch. Okay, so folks, so we can see here that, where are we at here? Okay, so this would, the way it's drawn, this might extend a little further, you know, something like this, and the same thing right here, okay? So I guess the point I'm trying to make is that we have 2 solutions. Okay, we have a solution approximately right here. I'm not making any claims on what the value of the solutions are, but we're going to have 2 solutions, all right, based on this very crude sketch. Now, again, it's the number of solutions we're looking at here that's important, not the actual numerical value. That's just a very crude hand sketch. So this right here would suggest 2 solutions. Okay, 2 solutions abbreviated, okay? Now, here's the absolute value definition. It's very well known. It's split into 2 cases, so that means we're going to have 2 cases when we actually analyze this. So we'll call this case 1 if you want. Okay, this is case 1 where x, if the input argument, x minus 5, 6 is the input argument here. So if it's greater than or equal to 0, the absolute value of it is just the object itself. And so that explains this analysis right here. Now, again, I left out a little bit of the work here, but we got everything to the right-hand side by subtracting x and adding 5, 6, and you get this right here. This would be minus 12, 6. But notice that this factors nicely into x minus 2 in x plus 1. Okay, so this would yield 2 solutions, right? This is equal to 0, so we get x equals 2. Now, without the graph, we would say, okay, maybe both of these are solutions, right? But we can see from the graph that the only solution we're going to keep would be x equals 2, right? Now, you might think, well, wait a minute, what about this over here? Maybe that would be a solution. Well, one way to get around that if you don't trust the graph is realize that this right here also says that x is greater than or equal to 5, 6, right? All right, so that's a way, if you have any doubts, and it's natural to doubt, just based on the graph, but x is greater than, sorry about that, 5 over 6, right? X is greater than or equal to 5 over 6, so we definitely are going to reject this because this case indicates that the solutions for this case is strictly greater than or equal to 5 over 6. So we're going to keep the 2. Now, in a similar fashion, we have another case down here, case 2. And again, we're splitting it into 2 cases because the absolute value definition itself is a 2-case piecewise function. All right, and so if you're less than 0, if x minus 5 over 6 is less than 0, up here we did the case greater than or equal to 0, but if the only other possibility is this, but that means you have to apply a minus sign. You see a minus sign to make it positive. And so that has the effect of just reversing the order of these 2 terms from x minus 5 over 6 to 5 over 6 minus x when you apply a minus sign to the interior piece right here. And again, I've done some of the work for you just to avoid all the writing. Now this one's a little messier. We do the very same thing we did. We add x to both sides and subtract 5 over 6, and that gives you minus 22 over 6 right here. Now this one doesn't factor nicely, so we have to pull out our good friend the quadratic formula here. And so you would end up with x equals to, there's an understood coefficient of 1 right here, right? Understood coefficient of 1 right there. So the well-known quadratic formula, x is equal to minus 1. Okay, we're going to have the plus or minus going on here. You could complete the square here, I guess, if you wanted to. Now, so b squared is going to be 1. Now, this would be your b squared, and then you're going to have minus 4ac. Okay, so I'll just go ahead and write this down, minus 4. Now, there's an understood, your a is 1, right? Okay, so you're going to have minus 4 times 1, just for emphasis, times minus 22 over 6. Okay, and this is all in the radicand, and again, you divide by 2a, so this is all divided by 2, right? Okay, now let's see, what do we got here? Let's come back over here, folks. This would be the very same thing as x equals to negative 1 plus or minus. Yeah, when you do all the work right here, and I will skip more than one step right here, just as you end up with one. What we got here is negative 1 plus or minus. Okay, now you'll end up with the square root of 1 plus 44 over 3. Okay, all over 2. All right, now in a similar fashion, folks, x has to be less than or equal to 5 over 6, right? X has to be less than or equal to 5 over 6. Let me write that right up here. Or less than 5, 6. Okay, so we're only going to retain the negative solution here. Okay, now I forgot the 2 down here, but we can make it slightly neater, I guess. So the one solution we would keep from this one would be minus 1. Okay, minus, yeah, this would be 3 over 3, 47 over 3. So I'll just put, and there's really no need to, unless you just want to know the decimal, but this would be 47 over 3 in the radicand, or as the radicand. All over 2. Oh, that didn't last, did it? But anyway, y'all, this is supposed to be, let me. All right. This has to be over 2. Y'all, I'm going to make that a mini 2 because I can't skip down to the next. So that's over 2, folks. But anyway, this is the negative solution. If you go all the way back, okay, if you go all the way back to the graph, we got the easy integer value up here, 2, okay? But this would be, so this 2 that you see right here would correspond to this point right here, okay? Your x coordinate right here would be 2 something, right? I'll just call it y if you want to. All right, that's this 2 right here. And then whatever this value is right here, and again, this may not be scaled very properly, but that would, the x coordinate right here would be this value right here. Who knows what that value is? But anyway, folks, hopefully that's enough. We used the graph to indicate there would be 2 solutions. and we found both solutions. Okay, let me know what you thought. Hope you enjoyed.